All right, I know what you're thinking. Schmeck, I have absolutely no idea what you're talking about or how I'm going to use this. All right, well, let's just give you an example. If we were to give you four sets of quantum numbers, you should be able to tell us the identity of that electron. What electron are we talking about? So in this first example, we give you the physics notation. We give you the four quantum numbers, N, L, M, and S, and we give you their numerical values, 2, 1, 1, and negative 1/2. You should be able to tell us the chemistry notation and what electron this corresponds to. And now it's just a tutorial about how to use your quantum chart. So if N equals 2, well, the chemistry notation for N is just the same as the physics notation. It's just the same number. Okay. If L equals 1, remember L equals 0 is an s orbital, L equals 1 is a p orbital, and then L equals 2 is a d orbital, L equals 3 is an f orbital. So L equals 1 corresponds to chemistry notation of p. M of 1 refers to the orientation on the z plane, so pz, and then negative 1/2, and the chemistry notation is just a down arrow. All right, so where do we find this electron on the quantum chart? Let's take a look. All right, first of all, here's our quantum numbers that we're going to use to find this specific space in the periodic table. Now, I know I gave you the analogy of each electron having a social security number, and this is the four quantum numbers. I'm going to use a little different analogy that deals with a location. Okay, these quantum numbers refer to the electron's address on this quantum chart. And I like to think of the principal quantum number N as being what town it lives in. So this electron happens to live in town number 2. So you can find on your chart there are 2 places where you find an N equals 2. All right, so all of a sudden, with just this one number, we've narrowed down our search to 8 possible things. All right, so the other letters now are going to even focus us in further until we get to a specific box on the periodic table, a specific electron. All right, so L equals 1 means we are in a p orbital. So over here is L equals 0. So these two are out. All right. L equals 1 is right here. So now I've got it narrowed down to one of these 6 electrons. Okay, I think of the L quantum number as what block you live on, or what is your street that you live on. Okay, look, we have 4 blocks. We got an S block, a P block, a D block, and an F block. Well, this electron so far lives in town number 2 on the P block. All right, so now we can get more specific and find out what townhouse it lives in. Okay, each townhouse has 2 living units, an upstairs and a downstairs. Okay, so what house, what specific address does this electron have? All right, that's what the M number is. And M number of 1, okay, corresponds to electrons in the Z orientation. All right, so there are 2 possibilities here. So now we've got it narrowed down from 6 to 2. So it's either the 7th electron or the 10th electron. All right, now the next quantum number is going to give us which apartment in that townhouse does it live in. Does it live in the upstairs one or the downstairs one? Well, negative 1/2 corresponds to the downstairs. So now we can look in our boxes, and the 10th electron has the down arrow. So the 10th electron is represented by these 4 quantum numbers. It gives us a specific location on the table for every electron. Okay, so this is the 10th electron. All right, so we're supposed to sketch this electron cloud. Well, it's a p orbital, so we know it has the dumbbell shape, and the orientation, we will make this p orbital on the z plane, so it'll look something like that. And it's the 2nd p orbital, so it's 2pz right here. All right, after that, I think it's time for a little joke. So why do chemists call helium, curium, and barium the healing elements? Do you give up? because if you can't helium or curium, you'll have to bury them. Oh, good times. Well, anyway, back to business. In this next example, we are given the chemistry notation, and we have to come up with the physics notation. Well, the n quantum number is the easiest, because whatever it is in the one notation, it's the same thing in the other. So physics notation will be 3. All right, s orbitals correspond to an L of 0. The little dot corresponds to an M of 0, and an up arrow corresponds to positive 1/2. All right, you can always just look on the quantum chart to get these numbers. It's nothing you need to memorize. It's always on the quantum chart. So let's find the electron that has this address. Okay, this electron lives in the 3rd town. So if you look on your quantum chart, there are 3 possible spaces for this electron. So we've narrowed down the search from the whole table, okay, down to 18 electrons. So now we can find out specifically what block it lives on in this town using the L number. Well, L equals 0, or S. Well, that is right here. Here is the S block. So now we've eliminated 16 of the electrons. We know it is one of these 2 electrons here. Okay, so the M quantum number is going to tell us what house it lives in. Okay, well, you remember there's only one orientation for a sphere. So M number is 0. We know we are in the spherical orientation here. So we're still just limited to 2 possible electrons. The S quantum number is going to tell us which one we have. So this electron lives in the upstairs apartment, okay, plus 1/2. Okay, so this will be, okay, we have plus 1/2 here at the 11th electron and negative 1/2 for the 12th electron. We have the 11th electron. All right. So these 4 quantum numbers correspond to the 11th electron. All right, this would be an s orbital, and there's only one way to orient an s spherical orbital on 3-dimensional space. So you would just draw a sphere in there, label it 3s. All right, your turn to try one. Here is the physics notation, and you come up with the chemistry notation and what electron it is. Pause the video and try it out. All right, you should have gotten this chemistry notation, and it corresponds to the 43rd electron, and it would look something like this with the cloverleaf shape sitting on the X and Y plane.